Welcome to Olympian Water Testing, giving you the best in water analysis. Today we're looking at the effects of cadmium exposure on the immune system and immunoregulation. So when cadmium gets in our food, our water, or in the environment, what does it do to the immune system? Well, cadmium, a biologically non-essential heavy metal, is widespread in the environment, including the air, water, and soil, and is widely present in foods and quantum dot preparations. And CD enters the body primarily through inhalation and ingestion, and its biological half-life in humans is 10 to 35 years, so it can last quite a long time. Therefore, CD possesses long-term health risks. And while most studies on CD toxicity have focused on organ and tissue damage, the immunotoxicity of CD has drawn increasing attention recently. And CD accumulates in immune cells, modulates the function of the immune system, triggers immunological responses, and leads to diverse health problems. So a lot of people talk about, well, it affects gastrointestinal, affects the kidneys and the liver. And it can, but with a half-life that long, if it doesn't do those things, it can still cause problems for your cells, still cause issues for your mitochondria. CD acts as an immunotoxin agent by regulating the activity and apoptosis of immune cells, so it can kill immune cells, and alerting the secretion of immune cytokines, inducing reactive oxygen species production and oxidative stress, changing the frequency of the T lymphocyte subsets, and altering production of selective antibodies in immune cells. So what did they take a look at? They took at cadmium as a heavy metal, what it is, and it's actually a class 1 carcinogen as well. And further, CD cannot be metabolized by the human body and is difficult to excrete. And it can, as a result, it has a biological half-life of 10 to 35 years, and humans are at risk of CD exposure through ingestion from the water, grains, leafy vegetables, potatoes, seafoods, as well as inhalation. And occupational contact through CD occurs primarily through respiration, whereas in the general population, CD intake occurs primarily through food ingestion, recreation, smoke, inhalation, and in many other countries. And CD levels in humans have been found to exceed the tolerance of various organs and are associated with increased risk of chronic diseases, such as cancer, diabetes, and osteoporosis, very, very serious conditions. CD accumulation occurs in several organs and tissues, and CD causes acute or chronic toxicity in the lungs, kidney, liver, and bones, and can be absorbed into the blood from the lungs and gastrointestinal tract, where it binds to blood cells, thus affecting the blood system. And we have the graph right here of what cadmium can do, especially if it goes in water, seafood, grains and vegetables, oral intake. It affects the kidney, liver, blood, gastrointestinal tract, and bone. So this is quite serious on what can happen here. We can see the major routes of CD exposure and the toxic effects of CD on different organs of the human body. Now the exposure on the progressive lung, kidney, liver, blood, gastrointestinal tract, and bone. What does it do? Studies have shown the acute toxic properties of CD were observed in the air-liquid interfaceway models, which led to induced aberrant munitions expression and secretion, impaired cilia function, serous differentiation, thus impairing the function of the mucosal barrier in the lung and progressor. Also, the nephrotoxin substance with CD exposure blood in children, adolescents, and adults positively associated with the markers of kidney damage. Therefore, current exposure to low levels of CD may have adverse reactions in renal tubes. Then there's also the liver can have issues. CD induction liver tissue was induced to have liver panspermia and lymphocyte. Also cytosis of lymphocytes, lymphocellular microbubble fat degeneration. There's even blood issues with red blood cells significantly reduce the activity of red blood cells, superoxide dismutate, catalase, and increase the concentration of lipid peroxides. And gastrointestinal tract is one of the targets of CD action and causes acute inflammatory response in the intestines of mice, causing villainous damage to the intestinal tissue and accompanying the emergence of inflammatory cells. And also, in addition to the intestinal inflammation caused by CD exposure, CD intake was observed to alter the structure of the gut microbiome and reduce the relative abundance of lactobacillus in the intestine. And finally, bone. It was associated with changes in bone metabolism and osteoporosis, and there is growing evidence that CD has a direct effect on osteoblasts, which accumulate and induce apoptosis and osteoblasts as well. and as a result, CD accumulation can have toxic effects on the bones, thereby reducing the density of bone minerals, regulating the expression of bone formation genes, and affecting the activity of osteoclast and CA absorption, thereby increasing the risk of osteoporosis. So it can do a number of really terrifying things, and it can have a plethora of different conditions, even when cadmium gets in small amounts. And the more and more that gets there, it's harder to detox from it. As you can see, it has a half-life of 10 to 35 years, so it doesn't necessarily go away easily. Now, you can regulate your diet and make sure that you're eating a healthy diet and try and stay away from cadmium. But it's also a great idea that you periodically test your water to make sure that there's not elevated levels of cadmium in it, so none of these symptoms or issues manifest.